But in this video, I want to talk and give an overview about MongoDB. And where I want to start is where we left off in the other week when we were talking about JDBC, we were talking about XML. And I asked the question at the end, well, why aren't we talking about JSON? JSON has been more prevalent lately than XML, so why aren't we talking about it? And I said, we will. So I'm proud of you. Now we're getting back to it, right? And so this is a repeat of what we talked about, right? JSON is an example where lighter is better 80% of the time compared to XML. It's super easy to parse and encode. It's efficient at runtime because not only is it easier to parse and lighter weight, but it also works very efficiently with JSON. That's part of the reason I'm going to talk about Node.js. It's part of the reason we used in browser-based programming. And it's not a bandwidth or memory hog, right? Part of the lightweight part again. So it's better for internet applications, web applications, mobile applications, and the like. But how do you deal with such a lightweight format in a strongly typed relational database? So I gave you a quick example. I talked about the SQL draft standard, and I talked real quick about this extended type that we have in MySQL to deal with JSON documents, right? But as I said before, it's like, it's like fitting a square peg in a round hole, right? We're shoving documents. This is called a document. This JSON string, if you will. That's a JSON document, and we have heterogeneous ones in here. So this doesn't look like, right? This is a single column, but inside it almost looks like something that would be multi-value or have a composite attribute of structure. We can't really use that JDoc attribute very efficiently without pulling it out, taking a look at what's in it, and querying it, right? So it's in a relational database, and yes, they added the extensions, but it doesn't feel natural, all right? So let's talk now about what we wanted to talk about later, and that is something like MongoDB that is more natural for working with JSON, right? So MongoDB is document-centric. The document is what's called a binary object as opposed to JSON, which is textual, so think binary JSON. The data model is a document as an object, so the entire document is considered the thing that is stored, and that object can have sub-documents, so you can embed documents in other documents, if you will, and that's important because that gives us our first notion of hierarchy, right? Not being flat like the relational document, right? And then documents can be organized into collections, but one document doesn't have to be like another, right? The documents don't have to, now they can, there is an option in there, we're not really going to talk about in this class. You can do things that create schemas for documents with tools like Mongoose, for example, but that's not the natural way of dealing with documents. Documents that are around a common thing, concept, thing you're trying to model are typically organized together into things called collections. So those documents themselves are heterogeneous. So we have this heterogeneous type as well of things associated with each other in a single collection. All right, so we have both structure and heterogeneity added through this document approach. All right, within a document you have those JSON-like properties, the key values, like we were showing over in the MySQL example, and then each document is given a GUID, a global unique ID in the ID field. So when you actually go look at your documents and you look at your collections, you'll see unique identifiers have automatically internally been assigned, which is something you didn't see in the relational model. There are some, I took this table from the Mongo manual, but there are some analogies. This table is not meant to be a one-to-one, but there are some analogies between what you're used to doing in SQL or what you're used to doing in a relational database versus what you're doing in Mongo, right? So typically if you're thinking of a table models something, whereas a collection would model something, all right? But again, the Connect collection is going to have multiple documents in there, whereas a table is going to have multiple rows. But we know with a relational schema, those rows all kind of look the same, right? And I say kind of because sometimes when they don't, we may have nulls, right? You did all those modeling things where you're trying to partition out through referential integrity constraints to normalize your schema, or you're allowing the use of nulls in certain things in order to make that relational model work. In Mongo, you just have it as a document. It's heterogeneous. If you have fewer attributes, you just have fewer attributes. If you have more attributes, you have more attributes. If you have different types of attributes, you just have different types of attributes, and they're all together in the same thing, right? And here we call the thing a collection, whereas on the relational side, we call it a table. A column is like a field, and there's still indices, if you will. Now, one of the big ones is table joins. We don't really have the notion of a join anymore, right? We talked about last time of having to put together a conceptual object or thing in a relational database by tracing down from tuple to tuple across our referential integrity constraint to reassemble the entire data for that object, if you will. Here, the object's a document, right? And if we have subdocuments or extensions of it, those embedded documents are put physically inside of the original parent document, or they could be linked to that document by reference. So there are two different types of semantics that are provided. But in either way, we kind of got rid of joins, in a sense, by having these embedded documents that we can get in one query without having to join across one or more tables in a very expensive operations. We still have the notion of key fields. We still have group by, in Mongo it's called an aggregation pipeline. So other things that you want to do are going to feel a little bit SQL-like, but obviously you have to be aware of the data model that you're querying. And we'll talk about that in the follow-on talks. Right? I wanted to return back to that concept that you just learned in this class last week, normalization, right? That idea of organizing data in such a way as to reduce or eliminate redundant storage of the same values, right? That keeps your database smaller, more mathematically efficient, if you will. It maintains data integrity because you don't have things replicated. There isn't a chance that you're going to wind up with one change in one place and not change in another place. But and that's why you studied functional dependencies last week associated with normalization, so you understood the underlying properties. When you do it in a document-oriented store like Mongo, the factoring is going to be a bit different, right? The functional dependencies, you still have a notion of dependency across documents, but normally that's more of a factoring, almost like you would do an object orientation of common properties into a subdocument, or something that, again, you can, instead of just embedding the subdocument, you could link to it as well. So you do have this notion of a reference. So it's not a relational functional dependency that's set theory oriented, but something that is, again, more aggregation oriented, and it's almost like promoting common attributes in an object oriented sense. So that requires a factorization of the data to ensure that reuse across common documents. Anytime you do that, there is some extra work to put the object back together, but the extra work in a Mongo when you embed the document, again, is going to be less than what you do when you're joining across 2 or 3 or more tables to recover an object across your referential integrity constraints. All right? So we want to get that whole structure back in one atomic operation as opposed to doing a join-like operation that's very expensive. All right, and then the other part we talked about before was this concern with writes, right? Writes are becoming more prevalent with interactive, internet-oriented application. MongoDB supports atomic write operations. Write operations that are not multiple operations put together inside a transaction context. So you can do write operations atomic at the document level, which means you can write that entire document in one uninterruptible operation. That's what it means to be a document. Now, only one process can do it at a time, so we still kind of have some of that transactional oriented behavior, if you will. In fact, that atomicity that we're talking about is the first of those, right? That's the A in the ACID properties of a relational database transaction. So if we have to write a single conceptual object, a related set of objects, and guarantee atomicity, we can, you have to denormalize it to do it in a relational database, right? So you can write it to one table. You're basically putting things across those joins, right? If I have to write one conceptual object back out across referential integrity constraints in a relational database, I may have to write to 3, 4 tables and do an update across all those tables at a time, which means I've got to wrap all those things inside of one transaction context. In Mongo, I have to do that. I can write the entire document as one atomic write, including the embedded document. So again, I don't have to worry about wrapping multiple operations into a transaction so I can maintain atomicity. It comes with the database for free. So that's some of the low-level benefits of a MongoDB.